everyone, and welcome to the latest installment of the STEM Plus X webinar series. This one's all about maths and data careers. I'd like to start by acknowledging the traditional owners of the lands on which I am broadcasting to you from today. I'm on the lands of the Gadigal, Bidjigal people of the Eora Nation. So I'd like to pay my respects to elders past and present, and also acknowledge the tens of thousands of years of science, technology, maths, engineering, basically a long history of growing and sharing knowledge of First Nations people. My name is Lee Constable, and I am your host moderator for this session. I'm excited to be here today. And now also I'd like to welcome you to let me know who you are, also whose First Nations lands you're joining from. Let us know in the chat whether you're a school teacher, a current student, whether that's high school or university, maybe a careers advisor or a parent. Anyone is welcome in this session, so please feel free to use the live chat if you're attending live. I'd like to acknowledge our sponsors. Today's webinar is brought to you thanks to our sponsor, Queensland University of Technology, you might know as QUT. QUT is a university that focuses on practical learning and real-world projects and industry experiences provided throughout its degrees. Maths and data science graduates from QUT are recognised nationally as highly skilled emerging professionals, which is great. And students participate in a project unit led by an academic and an industry partner during their studies. So this provides valuable real-world experience and industry connections, making QUT's program unique in Queensland, which is pretty cool. So today our event is all about maths and data careers and study. There's a huge demand for the skills of maths and data, and new opportunities emerging across different sectors, from tech and finance to healthcare to sustainability and beyond. And of course, this opens lots of doors, but the question is, how do you get started? Today, we've got a panel of 3 speakers from different types of maths and data career stages and specialties that we'll be speaking to. And so I'll introduce them one by one, and then we'll get into more of an all-in panel discussion at the end. And of course, there'll be opportunities for you, the audience, to ask questions too, so keep that in mind. First of all, I would like to welcome to the screen Brynn Mackie. Brynn is a current mathematics and biomedical science student who aims to combine her studies to advance medical research and improve outcomes for cancer patients, which sounds like a great ambition to me. Welcome, Brynn.
Hi, Lee. It's great to be here today.
Well, it's wonderful that we're starting with you because you are earliest in your career. You're a current student and you're doing a double degree. Could you tell us a little bit about what your double degree is and how that works?
Yeah, absolutely. So I'm a 4th year student at QUT, and I study a double degree in maths, majoring in applied and computational mathematics, which is all about modeling. And my second degree is biomedical science. And basically, it sounds like a really big workload, but it's not. I do the exact same amount of work that a regular student would do. It's just half the work is math and half the work is biomedical science.
I love that. And I love that it's a combo maybe not anyone would think about, but how are you finding that they're pairing together? Do they go together well?
Yeah, absolutely. So I was exactly the same when I was in high school. I didn't actually know that the maths and biomedical science had an overlap at all. I actually started a maths and science degree because I was so convinced that there would be nothing to do with maths and biomedical science. And I switched after my first year of uni because a lecturer was researching in mathematical biology, which is that oversection of maths and biomedical science. So there is a lot of overlap, from modeling things like brain cancer growth to doing something like bioinformatics, which is where you're using statistics to understand how genes and that kind of thing works.
Yeah, you mentioned brain cancer modeling. How did you get an opportunity, sorry, to have this practical experience? What does that look like in your degree? And for anyone who's not familiar and thinks you just go to a lecture theatre and maybe some classes in the lab.
Yeah, so basically, I was able to take on some extra work as a part of my undergraduate degree by doing something called the Vacation Research Experience Scheme. which is an extra opportunity to do over the summer. So in my regular degree, I would do lectures and tutorials, lectures where you get taught the content. So the professor's kind of just like speaking to you about what you're learning, and tutorials is more of that classroom environment where they're teaching you're getting to do the work and you can ask for help. And this extra research experience scheme that I did, I applied for, and I talked to one of my lecturers, the same one that I switched my degree because of. And she was doing some work in modeling brain cancer. And I thought that was really cool. Asked if I could come on for the summer, applied for this vacation research scheme, and did that for about 10 weeks, which was a really fantastic opportunity to kind of apply what I learnt in the classroom to some real world research that was happening. And I believe that research is getting published as well, which is a great opportunity.
Wow, publication before graduation is wild. That's amazing. Congratulations. We've got some people in the chat. I can see Linda joining us from Noongarland, Jobs and Skills Centre in Perth. Amazing. Olivia, hello. You're also a data science student at QT. That's great. So Brynn, we will be talking to you more later in the panel. Brynn has an amazing, I only mentioned a couple of things that she does, but she has an amazing full bio of experience that you'll be able to see from the event details and in the chat. So we'll come back to you, Brynn. Thank you so much. I'll now introduce our next speaker in our lineup, who is Rob Lucas. Rob is an applied and computational mathematics graduate who turned a passion for maps and transport systems into solving complex problems for smarter planning in industries like rail, mining, energy, and logistics. Welcome, Rob. Tell us all about what your job title is and what that means and looks like.
Yeah, for sure. Good afternoon, Lee, and hello, everybody. So I am an industrial mathematician, and essentially I solve a kind of problem where if you can describe every possible combination of things that could occur, and there might be millions of those, we solve optimization problems. So we search through all of those options, which is very computationally intense, and find the best possible one. And the best changes depending on what you're optimizing for power plants. You want to make sure everybody gets power safely at a good price. For train crew, which I work on at the moment, we need to make sure that every train has a driver and they all end up back where they started. And then for mining, mining is really, really expensive. So we need to balance the cost of doing it against the benefit of getting these minerals out of the ground. So the best changes, but the process doesn't. And it's using all this data to find excellent solutions.
So all these different problems where, math ends up allowing us to find solutions or little areas where we can make improvements that we might not otherwise.
Yeah, absolutely. And it also takes a lot of the work that used to be done by hand out of the process, which means that if your job used to be making one plan and it took a week, and by the end of the week you had to do that because that was all you had, now you can generate 50 a day and you spend a lot more time reviewing them and picking the best one. And that is still a really rewarding job, but it means you actually get really good and interesting results. And
awesome.
helps us with that.
I love hearing that your title, industrial mathematician, and mathematical data optimization. But what was your journey into this, and why do you think you love mathematics and what you do?
Yeah, absolutely. So I studied applied and computational maths at QUT. Technically, the field I'm in is called operations research, which is another area. But I would say that the skills translate really closely. Any sort of problem solving data mindset helps a lot. And then I started in consulting. And what I've realized is, yes, we do maths a lot, and it's my main job. But what we spend most of our time doing is talking to people to figure out what their problems are, helping them define them really clearly and translating them into mathematical language. And then we can do the maths, solve the problem. And once we've done that, we need to translate it back into language they can understand. I work with a lot of fantastic people in rail planning, in mine planning, power plants, and any industry, but they're not maths experts. So being that bridge and that sort of translator almost between what is the real world problem, how do we solve it, and then how do we use the results that we've got has been my journey, and I've really enjoyed it in all these different areas.
Yeah, so some people might think that you just go and do very solo work and you don't have to interact with other humans, but actually, it's quite social and
Oh,
communicative job.
definitely. And I do work with people who do work really solo and they really enjoy it. They get to spend a lot of time writing code and using their sort of super deep logical problem solving brains to come up with these fantastic computational solutions. But making sure the problems are really clearly defined and then communicating the results at the end is sort of my niche. So we work together really closely and it has good benefits.
I love that. You need all of the above. You need the people who can translate between. Thank you so much, Rob. We're going to come back to you as well, of course. And I know we've also had some audience questions pre-submitted, and feel free in the chat to put your questions and comments in there as we go. And I'll find time, hopefully, to cover as many as we can. The third and final of our three panelist speakers today is Associate Professor Helen Thompson. She's an award-winning statistician who uses data modeling to tackle real-world challenges in health, the environment, and society. Welcome, Helen.
Hi, Lee. Thanks for having me. I'm here on the lands of the Yuggera and Turrbal people at QUT. Happy to be here.
Thank you. Thanks so much. So we've talked about maths and data in a couple of different ways so far, but what does your work as a statistician in machine learning and in data science, what does that all mean and what does that look like for you?
So I thought I'd approach this by first kind of trying to clarify what the differences are between these areas. So we've actually got three different overlapping fields that are related to data science. So there's statistics, there's computer science, and then there's data science. And I kind of live in the world where there's the statistics and data science overlap. And a lot of people find it confusing as to kind of what the difference is between these three different fields, and that is understandable because there is so much overlap. So I thought I'd try to explain this through an example on road transport. So this is our traffic is important to understand and manage so that our emergency services can get to where they need to go safely and quickly. And it's also important for us to have safe roads for other vehicles and pedestrians. So this is actually touching on a project that I'm about to start on road safety around Brisbane. So here we can think about the statistician. So that would be my role. So the statistician would model and what I mean by model is help us to understand patterns in how the traffic flows. And we would use this, for example, to make predictions about where and when traffic jams are going to be likely, and also how certain we are around those predictions. So that's what the statistician does. When we kind of go over to the computer scientist, we can think about how the data is collected. So there's different ways that traffic data are collected. So it can be through traffic cameras, or it can be through sensors on the road as cars drive over, or even sensors that if you have a Bluetooth enabled mobile phone, you drive past these sensors and the sensors kind of ping where you are and collect your data. So the role of the computer scientist there is to collect and store and process that data so that it's in a form that's usable for the statistician to do their modelling. And then you've got the data scientist. Okay, so I don't claim that I'm a data scientist, because a data scientist is an end-to-end problem solver. So they can do the data collection, storage, processing, modeling. So you guys, well, what's the statistician and computer scientist for then? I'll get to that. So the data scientists also typically would produce a solution that whoever needs to make the decisions around traffic management, that they can understand it. And that might look like a live map that shows the current traffic and predicted traffic patterns. And this might be in an app, and you might be already familiar with traffic apps like Maps and Waze. So the data scientist kind of goes from end to end in the problem solving. Now, those three different roles, they all require the same length of training. So we've got a Bachelor of Maths for the statistician, Bachelor of IT for the computer scientist, and a Bachelor of Data Science for the data scientist. They are all 3-year degrees. So naturally, that means that the data scientists can't be as specialised in statistics and computer sciences as people who train specifically in those roles. And in organisations where they have very challenging problems that involve data, that is why you'll see these organisations employing all three roles. So there is natural overlap, and these three different roles need to know how to work together.
Thank you so much for that. That's a great, I love that just this one traffic example that we interact with every day can really allow us to see these different jobs that often go unseen while we're going about our everyday lives unless we're involved in it. And I know that there is some information available. You've got some of that in imagery and in a QR code available there for people who want to see the mathematics degree and the data science degree specifically. But there's other information on the QUT website for anyone who wants to have a look more in depth at that.
Yeah, so if you're looking at questions around careers and things, that's specifically what that link will take you to. So I think we might possibly touch on that if people have questions around that.
Yeah, definitely. If you've got any, your questions might be really practical questions about enrollment, about curriculum and things like that. You've got the perfect place to do that. So please do ask those questions. So now I wanted to hear more about the sustainability and health applications of what you do, because I think sometimes people think about mathematics and data and they think of the non-living world rather than the living world. Could you explain some of the applications of your expertise to that?
So in my research, I'm really highly motivated by working on projects that bring about benefits to humans, to society and to the environment. So one example is a project that we worked that I myself and my research student worked on, and that was to support very young children with developmental delays. So we wanted to kind of understand the trajectories, the growth patterns of these developmental patterns of the children, and try to develop a model that allows us to provide personalised interventions for those children to help bring them back to a level of development that will help them succeed when they go into school. Or another more recent one is the Australian Cancer Atlas. So that's publicly available. It's out there on the website. If you search Australian Cancer Atlas, it will take you there. And that one I love because it's really impactful. Everybody in the public can access that. You can have a look at the prevalence of cancer, the risk factors of cancer across Australia. And so this is really helpful for those who are impacted by cancer, but also it kind of reaches all of the politicians and policymakers who help support healthcare services, to bring about better health outcomes for our nation.
Thank you. Yeah, and this can be used, like you said, not just for everyday people, but those policymakers and in the public health sector to be able to make better decisions on a system level. So thank you so much for that. We will have a lot more opportunity to talk to Helen as well as our other panelists now, because we're going into more of an open Q&A. I've got some pre-submitted audience questions for everyone, but please do write in the chat if you have any questions for one or all of our panelists. It can be really broad or really specific. Don't be afraid. Also, Amanda has put a link in the chat to some more information about career outcomes and the mathematics and data science information. So please check that out as well. I wanted to go again to those pre-submitted audience questions. One question that we got, and I can hear this sort of question coming from lots of different students, current high school students, as well as people who might be thinking about new directions for their career. But what are the options after school? And do you have to be a maths whiz to be good at data science? That's one question from our audience that came through. Do you want to start, Brynn, and then I'll open it up to others on the panel?
That sounds great. So I guess in terms of your options after school, I think Helen summed it up pretty well before with that computer science, maths, and data science kind of options if you're looking for a math-based career. I think they're all really great. And in terms of do you have to be a maths whiz? Absolutely not. So you do not have to be the best at math. In my opinion, the most important thing is your passion. If you're really passionate about maths and you're really interested in maths, then you're going to put in the time and work to get that qualification. And more importantly, you're going to enjoy doing the work to get the qualification. So as long as you're interested in it, there are always options to do bridging courses if you're going to go to university to get you up to speed. If you maybe didn't do those math methods or those math specialists that are assumed knowledge on our careers page. But yeah, so there are always options.
Great, thanks. Rob, did you want to add something?
I think Brynn nailed it exactly. It takes a bit of passion and determination, certainly, and I'm certainly not across every concept, and I certainly don't remember all of those that I studied in university. And of course, we don't apply them at all every day. But being across the breadth of what tools are available, what techniques are available, and again, starting to form that language of mathematical approaches with real world examples and the things people do every day. It comes from practice, and certainly if you're passionate about maths, you can get the time to practice.
Great. It's good to know. One question I have as well, and that our audience was wondering, and this is for all of the panelists, we might start with you, Helen, is what was your journey into being interested in maths in the first place like, and from high school then beyond into uni?
I think this follows on with the question about do you have to be good at maths? I was naturally good at maths, and I agree that you don't have to be good at maths to go into a maths career. But when I was in high school, I didn't know what I wanted to do. I just picked subjects that I was interested in. And when I started at university, I didn't identify that I wanted to do maths. So I was kind of encouraged to do a broad degree, a Bachelor of Science. So again, this is another good example of pathways in. You can, if you kind of make a choice and you want to change, it's very easy to do that. So I was in the Bachelor of Science, and my career advisor had said, oh, why don't you just pick a range of subjects across all of the sciences? And I think over time, I just realized I was just kind of naturally more interested in the data science kind of areas, the maths, the stats, and the computer science. And I just kind of went with it. And I just kind of kept on getting naturally rewarded for it. Opportunities came up, and that's because there is so much demand in the workplace for people with these skills. So, you know, I was offered an honours scholarship. So I thought, why not? I'll keep going. I'm enjoying this. I was off, then that kind of led me into a job with the Bureau of Statistics in Canberra. I thought, why not? This is interesting. I'll give that a go. And then I kind of, was offered a scholarship to do my PhD. And I thought, yes, why not? And that was in Glasgow. And so, it was never an intentional choice. It was just a slow kind of realization. Up until I kind of was doing my PhD, where that was finally the point where I'm like, yes, I like maths. I should do a career in this. It's kind of been like a natural pathway, and there's been so much opportunity just because of the demand for it. So I've just enjoyed it, and I've just found it to be very welcoming and kind of, lots of opportunities. That I love the people I work with the entire way. Mathematicians and statisticians are the best people to work with. And maybe that's my bias, because I've just kind of vibe with people that are similar to myself.
That's great. I love hearing that. And also a great example that you can start really broad, trying out lots of different areas of a science degree and then, find your passion into maths from there. Thank you. How about you, Rob? What was your journey in, and when did you first realize you liked maths and wanted to go and study something like this?
I didn't know it was possible to just get a math degree, basically, in grade 10. And when I discovered that, it was a bit of a light bulb moment for me to go, wow, this is still quite general. So I don't have to maybe perhaps not commit to any specific discipline, but maths will allow me to go into anything. And interestingly, even though I studied maths, I'm really passionate about public transport in particular. And this is now I have the tools to help in those systems. And it's really fortuitous that picking such a discipline like maths allows you to go into whatever you want. So I think I always knew I wanted to go into maths, but I'm glad that I can now express it in terms of something I'm really interested in. So
yeah, I love it too, because often I find like it's when I go to take a bus or something or when I'm taking the train and I'm waiting for the train, I'm always thinking, how do they make sure that, but now I know, you know?
yeah, yeah, it's a
Not
really
only how,
interesting
but I
problem
know
to solve.
who.
Yes, exactly right. It's an interesting problem to solve, and it's great to have people who are passionate about the delivery and, of course, the problem solving as well. So, yeah, it's good. Being part of a team helps a lot, and as I said before, that translation aspect I'm really passionate about as well. So,
Yeah, thanks so much. And Brynn, I know you're closest to having recently been in high school, but did you love it before high school? And also, I know it as well is maybe too early and we never know what we're going to be into until we get there, but do you have any ideas about the direction you want to go next as well?
Yeah, absolutely. So I've always been quite analytically minded and I really, really love a good problem solving task. So I've always kind of lent towards math in that respect because it's like all throughout school, this is the problem, it has an answer. And I just really loved how clean that was. In terms of deciding to go into maths, when I was in high school, I grew up regionally, so I didn't have much exposure to any kind of math careers at all, except for engineering or being a math teacher. And neither of those really pulled at me at all. And I had quite a strong interest in health as well. So I thought, I'm going to be a doctor. But I hate hospitals, so that quickly diminished. And I kind of realized when I was in grade 12 that I couldn't imagine not studying maths because I just loved it so much. So that's when I started looking into maths degrees and kind of what I could use that alongside, got into math science, and then eventually changed into maths biomedical science. And at the moment, I'm looking at a range of career paths from something more math-based, which would be that kind of, I'm leaning more towards math research because I really enjoy the kind of stuff they do there. So specifically modeling anything to do with the human body.
Mhm.
And basically what that modeling means is taking the data maybe that other scientists have collected about something to do with the human body. So going back to that example about brain cancer growth, there are scientists that will measure that. And then I can take that data and make a simulation of it on a computer, which I think is really cool. And then also looking at other options like bioinformatics, which is a little more biomed heavy.
I love that. And I also, as someone who also did a double degree, I love it that it allows you not to feel like you have to choose one thing if you are someone into lots of things. So, and it's nice that even though you decided you didn't want to necessarily be a medical doctor in a hospital, that biomed love came back in a different way combined with maths. So that's great to hear.
Yeah.
Thank you. I'll go to another one of our pre-submitted audience questions. This question is, who are the people that you look up to and inspire you in your line of work? Did you want to go first, Helen?
Yeah, sure. I have a lot of very inspirational people that I work with. But if I had to single out one person, I would say it's distinguished Professor Kerry Mengerson, who is a colleague here with me at QUT and in our QUT Centre for Data Science. Being a female in the data science discipline, I think it is important to have good, strong female role models, and that is exactly what Kerry is. She is a prime example of someone who is immensely successful in her career, who makes she's interested in the same kind of research that I'm interested in, having real impact across a range of industries to improve outcomes for society, for people, for the environment, and she has a family as well, and I have a family, and it's really great to be able to have someone to look up to who kind of goes, you did it. I'm going through it now. I can see I can get there. You've done it. I can see the pathway. And she's been really inspirational in terms of just my career as well as my research, and also bringing me onto some really interesting projects where I have really kind of got some satisfaction in getting some really impactful outcomes.
Thanks so much. I love that. And yeah, it's why it's great to have lots of different people with from different walks of life with different lives in all fields, but fields like maths as well, because like you said, you could see it, you could see someone else doing something the way that you wanted to do it. Rob, how about you?
Yeah, absolutely. I work with a lot of fantastic people across all sorts of problems, and I really admire people who are focused on solving problems that they're good at, but are also willing to take in other perspectives as well. Especially in something like maths, you could be quite single-minded on exactly the outcome that you're working towards on these kind of problems. But if you can step back, take it all in, figure out why we're doing it, and if there's ways we can change our process to help everyone a little bit more, even if it's not something that's necessarily mathematically optimal, it might be socially optimal. Then that's really nice. I think my first boss, who hired me out of university and was not a mathematician, but certainly an excellent mentor, Sally. She is someone I definitely look up to. She's an incredible communicator, and even though I live in my maths world and really enjoy it, it's seeing people who are passionate about things. In this case, it was the public transport again, and people who are happy to help and guide you on your career and impart wisdom that they've learned. I really appreciate that. So, yeah.
Yeah, and it's great that you identified a communicator too, because obviously that's a big part of what you need to do all the time.
Absolutely. I would say in our line of work, it's great if you can solve the problem, but if you can't convince someone you've solved it, then it becomes very difficult to move forward from there. So it's certainly something that's very important.
Great. Awesome. Thank you. We've got another 12 minutes. So if you did have any more burning questions, those of you who are here live, please ask them. But otherwise, I've got plenty more in front of me already. Brynn, I wanted to ask you, well, also that question about if there are specific people that inspire you, but also if you had any advice for other people who might be in high school or even early in their science study or math study, sorry.
Yeah. So I'll tackle your first question first. So in terms of people that inspire me, probably my summer research supervisor, Dr. Adrian Jenner. She was also one of my very first lecturers at QUT. She's just amazing. She's very, very passionate about maths, and she's a really fantastic teacher. She taught me abstract reasoning, which is notoriously one of the most difficult subjects you do in first year maths, and she's just very well loved in the student body for being able to communicate that so well. And yeah, similar to Helen, she's Dr. Adrian Jenner's had a very similar journey to maths as me. She was also a regional student and moved for university. And so it's just nice to see someone else kind of making that journey that I want to make and being like, I can do it. There's someone who's been very successful.
Yeah, and do you have any advice, maybe even specifically for other regional students too, because you've mentioned that?
Yeah, absolutely. In terms of advice for students in math who want to get more into math, do as many extracurriculars as you can. I used to do the Australian mathematics competition. I never used to do particularly well at it, but it was still fun doing it. And if your school offers things like inter-school competitions, signing up for that kind of thing, just really getting as involved as you can, I think is really important because it just allows that passion to grow and for you to explore that area, those different areas that you might be interested in a little bit more. And just specifically for regional students, attending stuff like this is really good. Making use of the online space is really important to try and get some exposure to different things. Because when I was in high school, I would have no idea what Rob and Helen's jobs were simply because they don't exist all the way out in Gladstone. So yeah, kind of doing these kind of things, learning more, doing that little bit of research is really helpful for you to be able to explore those different career paths.
Yeah, great. Thanks so much for that. As Linda says in the chat, mentors and role models, so important. I'll now go to our other panelists. Who wants to go next in telling us any practical advice you have for anyone in our audience looking to pursue maths and data?
Yeah, I might jump in. I will always tell people to follow your passions, follow your interests. If you are naturally interested in something, then you will have the desire and the persistence to kind of keep going with it. Now, also touching on some of the stuff that we've already discussed, and Brynn's a double degree student. I know, Lee, as well, you said that you also did a double degree. And you've commented that I didn't start in a maths degree. So is it do what you're interested, follow what you're interested in, and double degrees are really valuable to pair with maths. So any field that has any quantitative aspect to it, you'll see benefits in doing a double degree paired with maths. It will allow you to pursue those interests that you might have in the mathematical areas as well as other areas, and open up further job opportunities.
Yeah, I mean, researchers across fields use data even outside of STEM. You know, people who are working in archaeology use data, social scientists use data. So it's a really great tip. Thank you. How about you, Rob? Any practical tips for people?
I think focusing on breadth is really important. So reading widely across a wide range of disciplines. Math is a great central language you can talk about anything in, but knowing what's out there is really important. So I studied a math degree, but I got a minor in chemistry and a minor in mapping, spatial science. I'm not a chemist or a spatial scientist very often, maybe for fun at home, more on the spatial science side, but understanding that kind of work has helped massively throughout my career, and again in communicating with people who do things that are completely different to me, but then we can get back to a sort of similar language. So I really enjoyed that. Otherwise, spending time with people who are mentors, and then not being afraid to teach earlier than you think in some cases, even possibly not in a formal setting as a job, but even just if you see people struggling, if you can explain a concept to them, I almost guarantee you that you'll start to understand it better yourself as well. And so make sure you know a little bit about what you're talking about, but once you do, and you're confident you do, sharing the knowledge, it only multiplies knowledge, and you gain a deeper understanding as well. So at least I do. I really enjoy that.
Yeah, that's a great tip, because I mean, teaching, like you mentioned, it's benefits in both directions, I think.
I'm sure that we've got a lot in the chat, and certainly maybe Helen, you found this as well, but I never felt like I was ready to be a teacher. But as soon as I started, I thought, wow, if I can communicate these concepts across, it does help me as well. So
yeah.
Yeah,
absolutely. And yeah, they say that there's no such thing as a wasted education. It's also sometimes nice to study something and go, not for me. That's totally fine. Amanda's added in that Brynn mentioned the vacation research experience scheme. There's a link to that, as well as maths double degrees. So you can see the different things that at QUT where maths can be paired in a double degree. We've still got time for another of our audience questions, which is about emerging fields. What do you think are some of the emerging fields and careers for data scientists and mathematicians in the next 10 to 20 years? It's hard to predict, but do you have any things that you speculate are going to emerge, Helen?
Yeah, so I might be stealing some thunder from the mathematicians and the cryptographers here, but we've got quantum computing is fast approaching. What we don't have is the mathematics to support quantum computing. So in that kind of that time frame, when quantum computing hits, that's all of our cybersecurity compromised. Right, so we need to be working on things now so that when the computers are built, there needs to be algorithms behind those to make things work. And so we need the mathematicians to start developing those algorithms. And we need students to be coming through university and being trained in those areas so that they are ready to hit that job market with those quantum skills. So that's one area that is very fresh, that we really do need to start skilling people in that area, because when it hits, it's going to be very rapid. So yeah, getting people trained up and out there. And we also know that Gen AI and AI in general is a very big and rapidly evolving field. So another emerging area, which I sort of just kind of started an area of research in, is around responsible AI. So AI can often be a black box. And so one area of research that so research at the moment, but in 10, 20, 10 years time should be things that everybody should understand, which is around explainable AI, taking that black box away from AI so that we can understand what it's doing and that it's doing something sensible and that it's doing something ethically responsible.
Yes, please, future students, sort that out because I would love you to explain AI to me so that I can feel like it's being a positive thing for society. Anything else, Helen, before we move on?
Oh yeah, there is so much. Precision medicine. So we with the advance in the technology and the AI that it allows us to advance our methods and our computation that allows us to develop very targeted precision medicine. So that is an excellent area that's related to what Brynn is doing. So if you were to combine data science or maths with biomedical science, that kind of allows you to work in this emerging field of precision medicine. We've got, there's ongoing climate and environmental modelling challenges. And again, the growth of computing and AI that's happening at the moment allows us to do more when we're not so as limited with what we can do with our maths to try and solve these climate and environmental challenges where we're trying to understand what the future trends are in those spaces. And so you'll notice as well that these are not areas where you are just doing maths or just doing data science. It is so key to be able to work with not just that where I'm talking about statisticians and computer scientists and data science working together interdisciplinary. We need to reach out to those other areas where we're applying and really understand what's happening in those areas to really bring some impactful change.
Yeah, basically what I'm hearing is name a problem and
anything with
data
data
can help.
Yeah.
Yeah, thank you so much. Do we have anything that you wanted to add, Rob or Brynn, on that point?
Yeah, for sure. I think absolutely. I think something that underpins a lot of what Helen was saying was having an interaction between computer systems and I'll say the real world and making physical changes based on the information that we can get out of AI and the algorithms that we've developed. So I'm really interested in that sort of interface between the physical and the digital. I think that is a lot of potential there. And then the other one is when I was studying math, everybody said, "Are you going to become a math teacher?" And I always thought, there's so many more possibilities than that out there. But funnily enough, the more I think about it, education is changing massively, and how people learn and engage with technology that's so advanced at a fundamental level, bringing everybody up to speed on that. Exactly like you said, if someone could just explain AI, it would be fantastic. I think calculus didn't exist before Newton invented it, and now we do it in grade 10.
Yeah.
So what will be the grade 10 curriculum of the future, where it's pinned on, multi-dimensional large language model training or something like that. So thinking about how we get everyone up to speed, everyone around the world, I think that would be fascinating. I'm looking forward to that.
Yeah, that's a really good point. Even in a well-established career that most of us are familiar with from a very young age, like teaching, when it comes to maths teaching, there's a lot of emerging fields that you need to not only understand, but be able to translate to different levels. Yeah.
And I think we might need to teach a lot of adults more math as well. If they didn't enjoy it in high school, it's never too late to learn. And that's going to be a very interesting journey.
Yep, never too late to learn. Love it. And we are only coming up to the very end of this. So Brynn, how about you? What are you seeing or what are you hearing from fellow students about the fields they're seeing emerge and they're thinking about?
I think within uni, the biggest one people talk about is definitely AI. We talk a lot about AI and machine learning, which is really interesting because we don't delve too much into that in the maths degree at the moment. They definitely do in computer science, but machine learning is a really big area in terms of maths research as well. So at the moment, I'm looking at getting involved with some research to do with machine learning and neuroimaging data And so it's really that machine learning aspect is really important for crunching that loads and loads of big data. So that's a rapidly emerging area. I think it's becoming more and more prevalent as we have more and more data that's collected. Thinking about that, the road scenario, that's a lot of data there. There's a lot of data that gets collected on people's phone. There's a lot of health data, thinking about the human genetic code, lots and lots and lots of data in the human genes. So I think machine learning is a big one for me.
Yeah, lots of data. I'm thinking about my personal data. I learnt the term digital hoarder recently, and I think it applies to me. So yeah, it's absolutely something we need to think about is how do we deal with all this data, not just how do we collect it. That brings us to the end of our 45-minute webinar. Thank you so much to all our panelists, but also thank you to everyone in our audience who has been here live, but also to you at home if you're watching this back. In closing, I just wanted to let you know that you can learn more about maths and data careers by heading to careerswithstem.com, where you can search maths or data by your X, and you can find out what that is, your passion, interest, and industry. And you'll also find the latest issues of Careers with STEM, Maths and Data. And you can download a brand new Why Study Maths and Data poster. So that can be a really handy one. You can see that on the screen here. Thank you again to our panelists for giving us their time and expertise and experience today. And thank you to our sponsor for this STEM Plus X webinar, QUT. If you'd like to learn more about QUT's Maths and Data degrees, visit qut.edu.au. You can search qut.edu.au/mathematics. Thanks so much again, everyone, for joining us online today. We look forward to sharing more STEM plus X careers with you in the future. Thank you.